Good morning, boys and girls. So today is going to be problem 2.3, the distributive property within the quadratic concept. So I'm going to do some examples. This should hopefully seem relatively simple. Remember, I front-loaded you guys before spring break with all this thinking behind quadratic stuff. So hopefully this is, again, just review. If it's still difficult, totally fine. Come and see me today for questions, and I'll help you out. I'm going to do these two examples and then a couple more, and then it'll go rather quick. So if I got this right here, I want you guys to represent the area of this square in two different forms, so two equivalent expressions. So for instance, I'm going to break this down a couple different ways. I know that I'm going to add up all the little boxes here in order to get the total area. So I would do x times x, so this would be x squared, x times, which is this length, times this width, which is just x times 1, which is x. And then I got this length times this width, which is x times 2, so this is 2x. And then I got this length times this width, which is 2 times 1, so it's 2. So now I'm looking at it like this. I know that my area is going to equal x squared plus 2x plus x plus 2, or another way to look at this is just combine my middle terms. Those are my like terms, and I got plus 2. So that is that. That's one way to look at it. Another way to look at it is I got my length times my width. So I got literally x plus 2 times x plus 1. And this is where this should look relatively like review based on what we did before spring break. So again, this is another way to represent the area. And again, you can carry out FOIL, which is first, outer, inner, last, right? And you do these times these. So you're literally just doing x squared plus x plus 2x plus 2, which is the same as this, which simplifies down to the area equals x squared plus 3x plus 2. So that is the first part of today's lesson. You'll see some stuff like this. That's all they want you to do by writing equivalent expressions. I rewrote one of the questions you're going to see in today's work, and I put it right here. So I'm sorry, I didn't rewrite what was in today's work. I just made up another example that's like today's work. So it says a square has side lengths x inches. One dimension is tripled, then increased by 1 inch. The other dimension is decreased by 2 inches. So I can look at it like this, okay? One dimension is tripled, then increased by 1 inch. Tripled, then increased by 1 inch. The other dimension is decreased by 2 inches. So that's how you would do that. Now, again, I want to figure out an expression or find the area of this. So I would simply just do, we all see this, probably not. You're going to do 3x plus 1 times x minus 2, which again, FOIL, 3x squared, you'll see this, yes. 3x squared minus this times this is minus 6x. So this is plus 1 right there, forgot about that. Plus x minus 2, which simplifies to 3x squared minus 5x minus 2. Just getting us into the form of comfort levels of working with quadratics and carrying out the correct expressions. Now, another example or question you guys might have. Today's lesson will be really quick, I think, because of how much front loading we did. So write these in expanded form. So I have x minus 2 and x plus 3. There were a lot of questions yesterday about what expanded form means. And expanded form is just another way of saying carry out FOIL. So we got x squared plus 3x minus 2x minus 6, which equals x squared plus x minus 6. And then the last example would be something like this, 4x times x minus 3. Again, carry out the expanded form of this, so you're just distributive property. So this is going to be 4x squared minus 12x. I'm thinking these examples are gonna be enough for you guys today. I'm hoping it is, and if not, that's, again, okay. I'll be available at 1 o'clock for any questions you guys might have. I will see you then.